Alright, so we have labeled the different structures that we see in this diagram, right? Now we will focus on some pressures. There are four types of pressures that we will talk about, and please listen to me carefully. Outside the thoracic cavity in the environment, we have atmospheric pressure, right? So we denote that as PATM. Now, usually people denote it as 760 millimeter of mercury. Some also record the pressure based on the pressure of water. So we say centimeters of water, but in physiology, we consider the atmospheric pressure to be 0. So we will just say 0 millimeter of mercury. That's the atmospheric pressure. Okay. Now, inside the lungs, the pressure is called intrapulmonary pressure, denoted by P pulp. This is intrapulmonary pressure, meaning the pressure within the lungs. This is also called intraalveolar pressure. Different textbooks call it differently, but we will just go with intrapulmonary pressure. Awesome. Now, and at rest, this is also equal to 0 millimeter of mercury. Good. Now, the third pressure is between the parietal pleura and the visceral pleura. So the pressure in the pleural cavity, right here, this pressure. And this pressure is called intrapleural pressure and denoted by PIP. That is intrapleural pressure, and that is equal to minus 5 millimeter of mercury. Okay. Now there is also another pressure that exists across the pleura. So the pressure difference across here, and this is called the transpulmonary pressure. What is this called? Transpulmonary pressure. And the transpulmonary pressure is nothing but the difference between intrapulmonary pressure minus intrapleural pressure. So essentially, at rest, this will be 0 minus 5, which will be plus 5. So we'll look at that in a bit. But let's review this one more time. Outside, we have atmospheric pressure. Inside the lungs, we have intrapulmonary pressure. In the pleural cavity, we have intrapleural pressure. And the pressure across the lung and the visceral pleura, the difference is called transpulmonary pressure. Transpulmonary pressure is defined as a pressure difference between the intrapulmonary pressure and the intrapleural pressure. So let's look at some situations here. Now, when you are at rest, meaning just breathe in and breathe out. In between you breathe in and breathe out, is there a slight pause? So that is where we are looking at. So we are looking at when we are at rest right before inhalation. So, okay, you exhale first, you exhale, and then you will inhale, right? So in between that time. So between you exhale, and then you inhale, and then you exhale, right? So in between, we are looking at this point. So right before you inhale, the intrapulmonary pressure, which is right here, people, is 0 millimeter of mercury. the atmospheric pressure is 0 millimeter of mercury. And remember the intrapleural pressure, that's negative. The PIP is negative 5 millimeter of mercury. Are we good? Okay. And then what about the transpulmonary pressure, which is the pressure difference here? Transpulmonary pressure, remember, is P-pul minus PIP. So that will be 0 minus minus 5 millimeter of mercury, which will be plus 5 millimeter of mercury. Do you expect to get a question on this on your lecture exam? The answer is yes. So we just calculated the transpulmonary pressure before we inhale. Now, a positive transpulmonary pressure, like we see in this case, is actually good. When the transpulmonary pressure is positive, that means that your lungs can be expanded. So this is good. Now, let's look at these pressures when we are taking in air or during inhalation. It should not be at rest. Pressure during inhalation. Okay. Now the first thing that you need to remember is that when we are inhaling the air, the diaphragm and the external intercostals are contracting. So we know this. We know this from our previous discussion on inspiration, right? The diaphragm and the external intercostals are contracting at this point. When the diaphragm contracts, now I want you to focus on the picture. When the diaphragm contracts, it domes down. Do you see this? So the diaphragm domes down and the ribs are elevated. So the diaphragm domes down, we have elevation of ribs. What does that do? Will that increase the volume of the thoracic cavity? Yes. So we have an increase in volume of thoracic cavity. Agreed. Agreed. As the volume of the thoracic cavity increases, will the lungs be a little stretched as well? Yeah, so we will have stretching of lungs. As that happens, what happens when the lungs are stretched? What happens to the volume inside the lungs? We have increased volume of lungs at this point. If the volume inside the lungs is more, what happens to the pressure? Low pressure inside the lungs. How low is the pressure? How low? The pressure, the intrapulmonary pressure, reduces to about negative 1 millimeter of mercury. Obviously, the atmospheric pressure remains the same, which is 0 millimeter of mercury. And the PIP at this point even gets lower. This is minus 8 millimeter of mercury. Why? Why does PIP change? Listen. So the ribs are being elevated, right? As the ribs stretch, think about it. The ribs are being stretched. As the ribs are elevated, the parietal pleura sticks to the surface of the body wall. The parietal pleura is stretched. So there is stretching here. There is stretching here. As there is this stretching between the parietal and visceral pleura, obviously the cavity, the pleural cavity is little increased, which reduces the pressure even further. So the PIP reduces to negative 8 millimeter of mercury. Okay. So outside, let's review. Outside atmospheric pressure is 0. Intrapleural pressure negative 1. PIP negative 8. How will we calculate transpulmonary pressure? So this pressure right here. So transpulmonary pressure is P-pul minus PIP, right? So what's P? Minus 1, negative 8 millimeter of mercury. So that adds up to minus 1 plus 8, which is 7 millimeter of mercury, as mentioned here. Okay. Again, can I frame some delicious critical thinking question based on this. Of course, yes, that's why I spent all this time discussing this. Moving on to pressure during exhalation. Forget rest. So when we are breathing out, think about it. Which way is air moving? Air is moving out, right, from the lungs to the atmosphere. So obviously there is a pressure difference. We will have high pressure in the lungs as compared to atmosphere. Do you agree? So let's take a look. During exhalation, the diaphragm is relaxed and the intercostal muscles are also relaxed. So the muscles relax. I want you to remember this. Now, as these muscles relax, the volume of the thoracic cavity decreases. So we have decrease in volume of thoracic cavity. When that happens, what happens to the volume of lungs? Lung volume goes down. If lung volume goes down, what happens to the pressure inside? The pressure inside the lungs gets high, so high pressure in lungs, and that is actually about +1 millimeter of mercury. And as the lung pressure is more, another thing happens. The PIP comes back to -5 millimeter of mercury. So this is +1. This is 0 as always. And PIP at this point is -5 millimeter of mercury. Okay. Now, how will you calculate the transpulmonary pressure? This difference. Transpulmonary pressure, Ppul minus PIP. So that is +1 minus -5. This is 6 millimeter of mercury. So as we have more intrapulmonary pressure as compared to the outer atmospheric pressure, obviously we will have air going out of the body. Hope this is clear. Moving on to lung volumes and capacities class. Last week for our lab lecture on respiratory system, I made 2 hand-drawn videos for students. The YouTube links are up here. For those who are not in my lecture, for those who are not in my lab, students who are taking lab with Professor Lovero, please review these 2 videos because they talk about lung volumes and capacities. You watch these 2 videos and fill out your study guide. You fill out the study guide. Okay, yeah. And then students who are in my lab, obviously you watched these videos last week. You will watch them one more time to fill out your study guide. I'll stop here and then start with a new video.